And as soon as we get the setup here, I'm going to turn this over to Adam. But thank you all for coming. And we look forward to this discussion. We're ready. Nice timing. Adam, take it away.
Okay. Well, our first panel, does everybody have the program, is going to be on the Permian. And we've got three really terrific people to discuss this, Mark Berg, Joe Cardenas, and Robert Clark. I'm just going to give a very brief background on the three speakers, and we'll just jump right into it. Mark Berg joined Pioneer Natural Resources in 2005 and was recently promoted to be Executive Vice President for Corporate and Vertically Integrated Operations. The vertically integrated operations include pumping services, sands, well services, and so on. And his corporate responsibilities include oversight for land, regulatory affairs, government affairs, and communications. Joe Cardenas has been doing work in the upstream business for XTO for more than 25 years. He began his career in 1992 as a subsurface engineer for Exxon Company USA. Currently, Joe is the operations manager for the Delaware Basin, and he's a Texas A&M graduate, interestingly, as is Robert Clark. Robert Clark is a research director at Wood Mackenzie's Lower 48 upstream team, where he specifically works with the E&P service companies and investors in the North Texas market. This group, I think, is going to be able to tell us where things really stand in the Permian, and we will follow through with that across the day, and Rusty will talk about some of the challenges in the Permian as we get into the luncheon discussion. So we'll go in the order of Mark, and then Joe, and then Robert. The slides are up here, and Mark, over to you.
Great, thanks, Adam. I'm assuming the slide turning is. Oh, great. Okay, great. Thank you.
Okay.
Great. I'll skip that pretty quickly. I appreciate the opportunity to speak with you today. And as you might expect, Permian is really deep in the roots and runs throughout the lifeblood of my company at Pioneer. We really take our roots back to over 30 years in the form of Parker and Parsley, who started in the Permian really in the 50s and 60s before it became popular. Back in those days, and really throughout the period of time until you got into the latter part of the 2010-2000 decade, it was considered the largest uneconomic oil field in the world. And today, as a result of the technological improvements that have been developed by our company and XTO, other companies who are fortunate enough to have acreage in the Permian Basin, it is now competitive with the largest oil field in the world in Guar. And I'll speak a little bit about how we evolved to that position, but I want to give you a little bit more of a picture of some of the challenges we face today, as well as some of the opportunities as we look forward. Pioneer operates predominantly in the Midland Basin, so it's good you're here to focus on Delaware. For those who aren't familiar, the two primary basins in the Permian are the Midland and Delaware basins. It's divided by a platform called the Central Basin Platform. We operate around 800,000 acres in the core of the Midland Basin. And this shows you the growth that we have seen since the advent of horizontal drilling and the development of the oil shales in the Permian. And you can see the growth has been exponential. Prior to that time, all of the drilling was all revolved around vertical drilling. And one of the things, for those who aren't familiar, that's unique about the Permian Basin is there are multiple depths of shales that are all productive zones. They're all source rocks, and when properly entered and fracked, and developed, they're very productive. And in the last few years, as you've seen this growth, there's been predominant focus on 2 or 3 of these zones. But there are multiple others that will be proven up over the coming years. So when we talk about the kind of resource that we have in the Permian Basin, it's really a multiple of what you see in some of the other oil and gas shales around the country where there's maybe 1 or 2 zones that are prolific. This really highlights what's occurred in the shale plays in the United States since the OPEC decision is 2 years ago this month. And the story that underlies this in one of the other slides is when the decision was made to focus on market share versus price stability with OPEC, it really posed a challenge for the operators in the United States to bring their cost structures down, focus on the resource, and be more efficient and see if the ultimate costs of producing a barrel could compete in a lower price environment. Everyone will remember the dialogue that went back in 2014 as there was, after the initial shock was, okay, well, when is it going to go back to where it was? And I think all of the industry today expects where we are today is the new normal. And the real story behind the Permian Basin is how, as an industry, both focusing on costs, focusing on efficiencies, and focusing on productivity of our well, we were able to become competitive. And that's really why you see the growth curve in the Permian Basin over this period of time. While some of the other resources didn't have the same competitive ability for a variety of reasons, some might be associated with getting the product out, some might be associated with rock, some might be associated with whether you're dealing with crude oil, condensate, or gas. So it's a mixed story in terms of why you see the growth from the Permian. But in the final analysis, it came down to the rocks, and it came down to the industry's ability to adapt. This tells pretty much the same story of what's happened during the course of the downturn and what's happened in terms of growth and what the impact of horizontal drilling has been. Going a little deeper into this time period from 2014 to today, basically what we saw as an industry was an opportunity to first reduce our costs through reducing service costs, and second of all, getting to the rock in a more extensive way, and third of all, is becoming what we see as a manufacturing operation. Today, different from the traditional oil and gas business, when you're operating in the Permian, there's no question about the resource, it's there. The real question is how efficiently can you get it out? And so what's happening with the resource companies and what's happened in our company is we're applying a manufacturing model. It's all based on efficiency, it's based on limited downtime, it's based on reducing your times in drilling and completions. And the next phase, which I'll spend a little bit of time talking about, is leveraging the huge amount of data and the opportunities that we have to really advance technologically, not only on subsurface, but also how we manage our operations and gain some of the benefits of big data. And that's really what we see as the next major efficiency as we look forward. Again, this tells the story of what's happened with well productivity. And the drivers that have occurred over the last few years really have been a combination of what we like to say, hitting the rock with a bigger sledgehammer. Part of it is associated with the appropriate spacing, and when you're dealing with multiple zones, some of it has to do, as Frank says, on frac hits, on making sure that you've got appropriate spacing so that as you're fracking the resource, you're not inadvertently impacting other producing wells. But it's particularly tricky when you're looking at multiple zones. So it's not only the spacing of the wells on a map view basis, it's also spacing them vertically so that you're hitting the reservoir you want and you're not invading other reservoir that you could better resource. What we've found and the industry has found as a whole is by bringing our clusters closer together and by hitting the rock with larger volumes of water, more sand as proppant, and basically breaking more rock closer to the wellbore, that has delivered a tremendous amount more resource. Also, having the efficiency of being able to drill longer lateral wells On average, we're drilling somewhere between 7,500 and 10,000 feet on our laterals, and having the acreage position and the regime that allows that sort of length of drilling has been very critical to the economics, so that you're not having to drill 5,000-foot wells, which would increase your costs, reduce your efficiencies, and also reduce your economics. As I mentioned, there's also been work with the service industries to reduce service costs. As we move forward, and particularly in an area like the Permian where there's a lot of demand for resources, and we can speak about that later during the Q&A, cost inflation is inevitable. It's going to happen, but when you're in this sort of price environment, it's something that we have to watch. But our best way to manage costs is both through efficiencies running our own operations. We do have our own vertically integrated operations, so we control a lot of our third-party costs, as well as maintaining the kind of efficiencies and looking forward. There's a lot of opportunity, as I mentioned before, in capturing the data that we have and eliminating some of the redundancies that we have in our process, both above ground and below ground. Things like data analytics, machine learning, automation. Today, the industry, when you look at companies like Google and how they manage the vast amount of data that they have, our industry has, in one respect, has a lot to learn, but has a lot of upside as we tackle that kind of data and use it to build more efficiencies into our operation. Part of the story behind the Permian is the ultimate costs that we incur for producing an incremental barrel of oil. And what this shows you is where the Permian Basin lines out with the other basins. And you can see why in a $40 to $50 environment, Permian has remained competitive. Basically, we've brought the combination of our lease operating costs and all of our finding costs down to somewhere in the low 20s. And the real key is remaining competitive on that and being able to maintain that kind of pricing in order to be competitive in a low price environment. So Pioneer today, we're at about $20 a barrel in terms of our incremental cost of producing a barrel of oil, which will tell you we can be competitive in this price environment. It wasn't like that in 2014 when OPEC took on the battle over market share, but this shows you what ingenuity and what hard work can happen in the United States when you challenge us and we react to that kind of environment. Looking forward, this shows you what the breadth of the production forecasts are. This is a compilation of 12 research forecasts for the future of the Permian Basin. And you can see there's a wide range in terms of where the basin will grow. It's expected, right now the basin's growing around 600,000 barrels per year. So that will have the basin at over 6 million, or over 3 million next year. The ability to continue that compounded growth, there's certainly barriers to that kind of growth as we move forward and as we scale up. What this chart shows you is that of the top 17 producers in the basin, there are about 110,000 drilling locations that could be prosecuted over the next 10 to 12 years. When you take the drilling plans of the top drillers and you look at the sort of infrastructure that's required, the kind of labor that's required, the activity that's involved, the number of rigs that get brought to bear, this points to 191 rigs today. And so as we move forward, there's a tremendous amount of resource that has to be brought to bear to bring this asset forward. And we can spend some time talking about that and the constraints associated with it. I can tell you at Pioneer, our primary focus is workforce, having the equipment to operate and complete our wells, primarily in pressure pumping services, sand, and water. I thought I would briefly touch on crude exports because this is an underpinning that's critical to the success that we've experienced in the Permian and the future of the Permian. When the export ban was lifted a few years ago, the thought was that it was important for the survival of the industry, but it's really played out in ways that's almost an understatement. During this period of time, you can see on this slide what what's happened with the spread between WTI and Brent. And you can see also what's happened with exports being at up roughly around 2 million barrels per day today. We have the facilities in the Gulf Coast to be at roughly 3 million barrels per day of exports going into next year, and plans are underway to get it up to about 5 million barrels per day. Looking at that and recognizing you've got about 7 million barrels per day of refining capacity in the Gulf Coast, you can see why it's critical that we have the ability to become an exporter in this country with the kind of productivity that we'll see from the Permian based on the forecasts that were shown on the previous slide. It's a huge success story in terms of bringing costs down for consumers in the United States, because I believe the ability to export has ultimately helped moderate oil prices globally, as well as allowing the U.S. producers to compete with foreign producers in OPEC. One other item that often comes up is constraints in getting our products out of the Permian Basin into the Gulf Coast. And basically the bottom line of this slide is to tell you that the midstream industry has done a good job so far in serving the Permian Basin producers and being able to get the product out. This is dealing with crude exports, or crude out of the basin. But right now we're roughly at 200,000 barrels per day of excess capacity. And with the Enterprise and Sunoco projects that are coming online next year, we think we'll be well served into 2018 and in the early parts of 2019. At the end of the day, the large producers in the Permian Basin, like Pioneer, are all looking forward to make sure that their product can get out. I mean, today we're getting around 100,000 barrels per day of our production to the Gulf, and we have plans underway to participate in many of these projects to make sure that our crude oil can get out of the basin. It's also important, on the previous slide you probably noticed that there's a slight uptick in the differential between WTI and Brent. What happens in that scenario is producers like Pioneer, who have the ability to export, can start getting a premium to WTI pricing on our products. Today we're getting roughly a $5 premium to WTI and being able to export our products, which is probably not sustainable long term. It will probably come down as more opportunities to export occur. But it shows you that when producers have the ability to export, there are ways to basically manage around the deflation in oil price that occur if the product got trapped. But this is of critical importance, but the industry, I believe, between midstream and upstream players are solving it. Also worth mentioning the growth of associated gas that's being produced in the Permian today. There's been some notoriety over the course of the last year that gas has actually surprised to the upside in the Permian. That we're certainly a participant in that. We've seen an increase in our gas production. It has not impacted our oil production. That's remained on forecast. And when you look at the performance of the old vertical wells that we've been drilling, drilled for years and years, the production that we see from gas on the gas-oil ratio is very much consistent with the way we see our vertical wells perform over history. So as in the final analysis, this is almost a byproduct for us. So it's very important for us to make sure that we have the processing ability to get it to the market, that there's pipeline capacity to get it out, and it's an incremental opportunity for economics on our wells. But this shows you that over the next 10 years or so, we're going to see as much as 10 BCF of growth in gas production alone, and that's going to play not only a role in the Permian, but it's also going to play a role in overall gas supply in the United States, and we believe will probably continue to keep gas prices leveled off at the sort of prices we've seen historically over the last few years. Worth noting also that one of the important elements for the industry and for us as a company is managing our emissions. and we can speak more about that today. But we like to put up this slide to show the kind of growth that we've seen as an industry and how the industry as a whole has managed emissions. It's not to say that we've done everything that we need to do or that we're doing everything that we need to do, and we can speak a little bit about that. But it does show, in relation to the kind of growth we've had, how we've managed our footprint on a macro basis. I wanted to spend a couple minutes talking about, more specifically, on how we manage methane. We were one of the companies that, and continue to be a supporter of the Quad OA new source rules that the EPA adopted last year. We're set up and are complying with those rules and are planning to continue to, regardless of what the impact is on the efforts with the EPA today, whether those rules get rolled back or not. As a company, we've been very focused on this issue. One, because we feel it's responsible as part of our footprint to manage it. There's also economics behind it in terms of capturing gas that can be taken to market. But through a variety of measures that we've taken through emissions controls on our green completions, vapor recovery that we've installed in our tank batteries on all of our new wells and a lot of our low rate wells that we've had that are vertical wells that have been legacy to the company for years. We were very proactive in leak detection and repair as a company before it became required. And we also participate in ownership, minority ownership, in the gas plants and gathering systems that serve our acreage in the Midland Basin as a way of assuring that we have the right pressures to limit the amount of kind of emissions that you could have when you have an overpressured system, and to make sure that our product can get out of the basin. It's also worth mentioning a little bit about water. You can see from the stats in here that today the demand for water in our pressure pumping operations in order to fracture stimulate our wells is significant. We've gone from 150,000 barrels per day of water in 2014 to close to 400,000 barrels per day in 2017, and that has the potential to quadruple over the next few years as we grow. And again, if you look at constraints, that's one of the constraints we focus on, and that the basin as a whole needs to focus on. Some of the things that we're doing to be good stewards in water use is we have dramatically reduced the amount of fresh water that we use in our operations, and that's through a combination of brackish sources that we've developed in the basin, as well as partnering with the cities of Midland and Odessa in using their effluent water. We're currently in progress on a project to build a $100 million water treatment plant for the city of Midland to take effluent water and use that in our fracking operations. Also, reuse is going to be a critical part of water use for both Pioneer as well as other operators. When you look at the amount of produced water that comes from these operations, it's a significant challenge as we move forward, and it's also something that we can take advantage of in terms of treating and reusing our water. The biggest issue is moving it around the basin and having it available and doing it in a safe way. Finally, I'll just touch briefly on the vision that Pioneer announced early this year. It was really started as a communication from our new CEO, who started at the beginning of this year, and the management team, on where we saw the company going, and it ultimately was something we decided, if we're communicating with our employees, we owe it to our shareholders. But basically, we're looking to grow to 1 million barrels equivalent in 10 years. A lot of people scratched their heads when you saw an independent come out with a 10-year forecast. And the best answer is the one our CEO gives, is we did it not out of hubris, hopefully not out of stupidity, but we did it because we think we can do it. And we think it's achievable, and we think it's an important item for our investors to understand and our employees to understand. But one final note that we like to emphasize is we're not just producing barrels to get them out of the ground. We're doing it, one, to do it in an environmentally responsible way. Two, we're doing it in a way that we believe is efficient and economic for our shareholders. And we're very quick to point out we're not going to be producing unless it's delivering the kinds of returns that we're showing in the Permian today, which drives the importance of maintaining or improving the efficiencies we have. And also, as an industry and as a company, we have a long history of outspending our cash flow, and especially during periods of time when we have growing commodity prices and people are chasing higher commodity prices. And as a company, and I believe as an industry, we're all being challenged, particularly if we're now in a manufacturing business, to spend within our means. So we have a big effort underway to make sure over the next few years that we self-fund our operations. We do have a very strong balance sheet, and that's been a hallmark at the company. But a challenge for us is keeping our economics and spending within our means. So with that.
This is the analyst perspective for the next 20 minutes. I've got about 15 slides that I'm going to go through that put some context around the Scoop Stack in Oklahoma, the Permian, and we'll try and dig into some issues around kind of why the Scoop Stack is so popular now versus a year ago. So we'll kind of tee up the panel after ours. And then we'll present some different Permian scenarios. The Permian's great, and it's going to keep growing, but there are lots of moving parts, as our first two speakers talked to. So I'm gonna dig into to a couple of topics that may change the trajectory of Permian growth over the next few years. Some for the better, some for the worse. Okay. All right. So this is a complicated chart, but I'm going to do my best to kind of break it down since folks don't have a printout in front of them. What this is a global look at new drill production about 8 years from now. So in the conventional world, what we would call a pre-FID or final investment decision, and then future lower 48 drilling. So going out 8 years, the drill bit's going to deliver, we think globally, we'll call it about 12 million barrels a day of new supply. That's the x-axis. Okay. The vertical y-axis is a break-even price, and what each one of those rectangles or boxes shows is for a different resource theme, what's kind of the range of break-even up and down, and then the width of the box is the productive capacity of that particular play or set of projects, and title is shaded in yellow. So in the most simplest sense, if you want to compete globally in future oil supply, you would want a box that's pretty wide and that's pretty low down on the y-axis. So I can produce a lot of the resource at a very low break-even price. And what we see here is the kind of dominance of yellow boxes on this graph. And these yellow boxes are U.S. tight oil plays. So the Wolfcamp is primarily Permian, or actually it is all Permian. That's the majority of all the Permian activity. That's very wide and it plots very low. And then the Mid-Con, which we'll talk about as well, the Scoop Stack, isn't as wide, it's not as big, but some of the projects are phenomenal, and that's why that box has kind of a low plot on the vertical axis. So big messages from this graph. Going forward, 8 years into the future, a lot of future supply is going to come from tight oil, and compared to themes like Gulf of Mexico, deep water globally, it looks very, very attractive. Okay, so in grand scheme of things, tight oil is pretty good. Okay, how did it get so good? How did it get so good? Well, it's hours and hours of discussion around all the reasons, but if you're talking about a simple break-even metric, so what oil price do I need for my project to be NPV neutral, you can really create two big buckets of variables, right? One would be productivity, so how much oil does my well produce and how quickly does it produce it? And then the second part of that would be cost. How much do I have to spend to generate that amount of production? Well, U.S. tight oil has become incredibly competitive because both of those variables have moved in the right direction at the same time, okay? So via technology, which will be talked about a lot and was touched on already, the wells are more productive, the ultimate volume that they produce is larger, but at the same time, we're spending about half the money to generate those volumes, right? So I think the third bullet down, the Delaware Basin, which Joe talked about as an example, EUR stands for expected ultimate recovery. So per lateral foot drilled sideways in a horizontal well, that metric has gone up, but the amount of capital required to do that has fallen in half. So when you put all this together, that's why break-evens have fallen to the level that they have. And just to put some numbers around that, lots of tight oil works now at $50 a barrel, which I'll show you in a chart. Back up 4 years ago, kind of the golden number for tight oil was about $65 or $70 a barrel, right? So percentage-wise, these are big, big reductions, okay? This graph here is a cost curve of just U.S. tight oil projects. And if you've ever studied electricity markets, you might say, well, this kind of looks like a dispatch curve, and it kind of is. What it shows on the x-axis, and this is all normalized, is the percent of undrilled locations, and then the y-axis shows the range of break-even prices required for those projects to be NPV neutral at a 15% discount rate. And each line is a vintage of data. And each line represents, there are about 1,200 company-specific asset models that WoodMac holds in its U.S. upstream database. And all of those points joined together ranked high to low results in this curve. So the top curve is what the cost curve looked like in 2014. The gray curve is what it was in 15, 16, and 17. So big message here, it's come down and down and down and down. Well, why is that, right? Well, a lot of it from the slide I talked about earlier, costs and productivity, but there have also been some other factors that have played into this, and one has actually been M&A in the Permian. So Joe touched on the big acquisition they did from Bass. You know, there are a handful of other big ones. Occidental made a huge one. EOG made another big one. When you look at those hundreds of thousands of acres in the hands of unconventional specialists versus the prior owner of that acreage, that means that that land is going to be developed and drilled in a much different fashion. So M&A has also added to a lot of this low-cost resource. This is land that will be developed now that prior to the transaction had a lower likelihood of being drilled, okay? So that's helped drive down the bottom part of that curve. You've also had some interesting exploration work and appraisal work in the Mid-Con in the Scoop Stack, which I'll talk about, and that's added a lot of low-cost resource in the middle of that curve. But just for kind of macro round numbers, this is the first time ever that WoodMac's modeled the cost curve where more than half of the undrilled locations break even at less than $50 a barrel. So another big message here, the Permian is really good, but it's not the only low-cost tight oil play in the country that has a lot of running room in a $50 price environment. Okay. This is a graph to kind of talk about this topic of falling break-evens, right? Because this is big stuff, right? The graph on the left is illustrative. It's real data, but the way the different wedges are designed are meant to be a little bit instructional. So the first bar on the left shows what an Eagleford Carnes Trough well broke even at in 2014, and it was about $49 a barrel, okay? If you fast forward from 2014, and the other speakers have talked about economics getting better, if you fast forward 2 years to 2016, that's that middle navy blue bar, and that break-even price is $35 a barrel. Well, how did it fall so much? Well, the waterfall wedges illustrate how it fell, right? And the big one to draw your attention to is that very tall green one. That's improved IP rate. So IP stands for initial production, and that's a good proxy of how productive the well will be, but it's a very good indication of what the well will produce during its first year online, okay? And through better fracturing techniques, through better completions, through better geologic modeling, through picking the best areas to drill, we saw the IP rates go up a lot, and that really drove a lot of the reduction in break-even down to about $35 a barrel. Now, this is where it gets interesting and open for a lot of debate. What is the break-even now? Did it keep falling at that rate? And the answer is no. Okay, it hasn't gone up. It's gone down a little bit more. Now we model it at about $32, $33 a barrel, and you'll see that that huge green wedge for improved IP rate, that's kind of gone away. Well, why is that? Well, a lot of the best locations have been drilled. So the IP rates haven't gone down. You just don't see that huge step change anymore. This is standard stuff for an oil field. It's like creaming curve analysis. You drill your best stuff first. So we're seeing that in a lot of mature oil plays. So the idea that break-evens are going to keep going down and down in every play isn't reality, because we drilled a lot of the best rock, and also we're in a period of service cost inflation. Okay? So break-evens are good now. Are they going to keep going lower and lower? Probably not, right? But there are some standouts, and that's the graph on the right. So we model a lot of projects at WoodMac, a lot of assets, a lot of companies' portfolios, and there's just a sampling of some of these project areas in the graph on the right. Some of the scoop and stack assets are in red boxes, and then some Eagle Ford plays, Delaware area called the Western Frontier. What those two lines show is what the break-even price for your kind of typical well was in 2016 versus what it is now. And when we sort and rank all of these drilling areas and projects areas, two of the places where we see the largest reduction, so places in the country where break-evens are still falling and falling aggressively, what floats to the top of that list? Well, it's two areas in the Mid-Con. The STACK, and STACK is an acronym, and the C and the K stand for two counties in Oklahoma, so Canadian County and Kingfisher. And then further to the south a little bit, the SCOOP area in south central Oklahoma. That's another acronym, South Central Oklahoma Oil Province. Those are two areas where the break-evens are falling aggressively as well. So as an analyst looking at this, we're saying, okay, in some areas their break-evens are flat, but in some areas they're still falling a lot. We need to keep an eye on that, and hopefully that's going to help tee up more discussion around the SCOOP stack. Here's some additional time slice data on the SCOOP stack. So the graph on our left shows what the WoodMac forward-looking view was for rigs and production in early 2016, and that's the navy blue wedge for production and the light blue line for rigs, versus what our most recent assessment is. And there's a huge change, and we'll put our hand up and say we did not see the break-evens falling as quickly as they did. The dark blue line now is our current view on how production will grow, and then the yellow line there shows what rigs actually did throughout 16 and 17. There was a huge explosion in rigs. A lot of this has to do with economics. Simply put, the wells are tremendous now. The wells were never bad, but some of the new wells, looking at 1.5 million barrel of oil equivalent ultimate recovery, these are big, big wells. You've got a lot of unique, very talented operators in the basin, private companies in Oklahoma. They're extremely experienced. They're willing to try new things. The completion designs have evolved very quickly, and the reservoir has simply responded. So the graph on the right shows different project areas in the Mid-Con, the number of remaining locations versus the break-even price, and there are a couple of areas that have thousands of undrilled wells that we think break even at about $40 a barrel. Now, the Mid-Con SCOOP stack has always faced challenges, and there's a speaker later on that's going to talk about the geology a lot more, but you may have heard phrases or words like the granite wash, right? A wash is a geologic term, and it essentially means kind of a lot of rubble. The way a lot of the reservoirs were deposited, there's a lot of variability. The rock is not the same as you move 5 miles, 10 miles in one direction. So that means you may not have thousands and thousands of wells in one company's portfolio that can deliver similar results like you might see in areas that are a lot more consistent. And certainly the Wolfcamp in the Midland Basin falls into that category where it's not as geologically complex. Okay, but big messages here, huge upgrade in outlook for the SCOOP stack, driven a lot by improved economics. It sounds simple, but that is the absolute truth on why the area is so attractive. And I put this in here just to kind of give you a generalized idea. When we talk about the stack area, that's more to the north in Oklahoma, and then the SCOOP area, that's a little bit further south, and then those boxes represent different formations that are the primary targets. And if you look at the slide and go, that's kind of complex, you've hit the nail on the head, because it is complex. It's complex to understand what reservoirs have the most potential in what areas, but through a lot of really solid appraisal work the past year, there's a lot more to go for, particularly in the stack in the northern areas, the northwest and the northeast. A couple companies to keep an eye on there: Tapstone, Alta Mesa, Newfield, Devon. These companies are doing some exceptional work in the area. So exceptional, how exceptional? Well, one way to look at unconventional or shale acreage is to look at it via just pure acres, right? So we know lots of wells are going to be drilled on close spacing. What's the size of the prize? Well, over the past year in Wood Mackenzie's geospatial modeling, we've added 1.5 million acres in the stack that works below $50 a barrel. Now, depending on what your assumptions are for how many acres are required per well, this is roughly 4,000 wells. And this is just added to our inventory numbers over the past year. So this is a big positive story for rate of change in the stack and how much could ultimately come out of Oklahoma, okay? This is another way to show the cost curve here, and I just wanted to pivot back to the Permian, because I know that's what this kind of first panel is about, to show kind of where we are now and the relative importance of the Permian. So each one of those lines or vertical bars, if you will, represents a specific project that we model, and the colors to pay attention to are the light blue and the dark blue. Those are essentially our Permian projects. And when we look at the dominance of blue in that graph, you can see that the lowest cost resource really sits in the Permian. So let's just set the stage for how good the Permian is. The Permian is much larger than Scoop Stack now, and that shows itself in a production forecast. So when we look at the quality of acreage and we look at the number of wells that we believe are going to be drilled and companies' budgets and ability to invest, this is our U.S. crude outlook for the next, we'll call it about 20 years. We see a peak in 2026 of about 11.5 million barrels a day. The bulk of that, without question, is the Red Wedge, and that is Permian, largely Wolfcamp, with a little bit of Bone Spring. If you're looking at some of the other areas, they are meaningful, and there's a positive story coming in the Eagle Ford, we believe, with higher prices. There will be a rig resurgence there. We believe the Eagle Ford can show a little bit more growth. The Bakken is shown in gray. That's pretty flat, although when we get out into the early 2020s, our models indicate a significantly higher price environment than we're in today, so we see rig builds there. But if you're looking for the elephant in the room when it comes to U.S. production growth, it is without a doubt the Permian, and these are WoodMac's latest numbers. Now, we need to keep in mind, though, that these are projections, right? So we are at 2017, and a lot can happen between 2017 and 2026. If we rewind 10 years to see what the oil markets looked like a decade ago, we can all agree that there are going to be some bumps in the road, okay? So a bit of work that WoodMac did over the summer involved looking at what some of those bumps could be. And this is some of the Permian scenario analysis that I wanted to share with the group. So just for perspective, let's look at some of the other big shale plays that have been developed over the past 15 years. And let's try and identify, don't necessarily want to say black swan events, but things that happened that were surprising to some that put a kink in the growth profile. So in the Bakken, there were huge issues with localized pricing and basis, and that showed its ugly head with some Bakken barrels trading at about a $15 or $20 a barrel discount. That slowed things down in the Bakken. In the Marcellus, the pipeline situation has been slower to come about. than many thought. That slowed it down. I'm just really brushing on these topics. In the Haynesville, that slowed down because of just the overall commodity markets crashing in 2008, 2009. In the Eagle Ford, sweet spots are much smaller than originally thought, so you can go around the map and say, goodness, in all these shale plays, things go great the first few years, but then we start to hit these kind of unknown variables. So what are some variables that we could study in the Permian? And we spent a lot of time researching this, and there are a few issues that have a lot of the technical subsurface community a little bit concerned. And it basically comes down to how many wells are going to be drilled and how closely they're going to be drilled together, right? And simply put, so much drilling is set to occur in the Permian that we are kind of in uncharted territory. So it's going to be something fascinating to see how it pans out. The graph on the left shows kind of total wells drilled in the Eagle Ford and the Permian by year. And the message here is that we remember the Eagle Ford boom in Texas in 12, 13, and 14. The number of wells drilled in the Permian this year and the next 2 years will be larger than the number of total wells drilled in the Eagle Ford during that boom. And this was pre-oil price collapse, right? This is a huge number of wells. Compound that with the idea that a well today is nothing like a well 4 years ago. So the graph on the right is a little bit busy, but essentially it shows the length of the horizontal lateral in a Permian well today versus that in an Eagle Ford well a few years ago, and it shows the number of stages in that well, so cluster stages, frac stages. That is an indication of how intense the completion is. Sorry. That's much higher in the Wolfcamp as well. So we're going to drill more wells, they're going to be longer, and we're going to stimulate the reservoir harder. Uncharted territory, this could introduce some new risks. A lot of people aren't overly concerned about the risks, and that's absolutely valid. You know, what we show here is Wolfcamp expected ultimate recovery. So this is how big we think a well is going to be in the graph on the left. And you look at that growth in the switch to horizontal drilling in 2010, and you say, my goodness, that is absolutely incredible. What would lead me to believe that we're at the peak? What would lead me to believe that wells aren't going to keep getting bigger? That's absolutely fair. There are lots of folks that believe that. But when you look at that issue, though, in more mature shale plays, you might see a slightly different story. And that's what the graph on the right shows. So when we look at the expected ultimate recovery and we start to normalize it for actually what we think the rock is giving up, so we normalize it for how long the well is and how aggressive the completion was, those lines are actually pretty flat. You know, and this is where it gets interesting for an analyst. Our job at WoodMac is to add to the debate. You know, there are some reasons to believe that wells will keep getting bigger, and there are some reasons to believe that wells might not get any bigger. Right? So, this is this argument that we coined over the summer called geology versus technology, and this tug of war when we look at future Permian production. And if you believe that there's a huge amount of upside in technology and better well placement and machine learning and more effective stimulation, and you look at the progress to date, you can build a thesis and you can defend the argument that my wells should be much larger than they are today. Why can't they go up to 3 million barrels a well? And some of the bullets there introduce reasons to believe that. You know, a lot of the analysis we do, we look at well performance, but every well, every piece of data that we get our hand on, that doesn't include the latest and greatest technologies. And those are out there, and they're not in every well, right? That's something very important to keep in mind as you model this. Frac design is continually evolving. Mark talked about that a little bit. Now there's a focus on stimulating the rock not as far out from the well, staying closer to the well, but having the fracture network be more complex. You know, that trend is going to continue. And when you think about the learning curve in oil and gas fields, the Wolfcamp, it's very early innings. You know, we've drilled maybe 10% of the wells. There's plenty of reasons to believe that wells do keep getting bigger. But on the flip of that, there are arguments to believe that maybe I already drilled my best wells. And we've gone in and we've looked at a lot of the well performance the past few months versus a couple of years ago. And there's a reason to believe that a lot of the acreage high grading was actually well high grading. So the rigs stayed in the best zip codes, but they also drilled the best locations. And there's a lot of work being done right now to understand the interplay between wells drilled now or over the next few years versus wells drilled a couple of years ago. They're being spaced very closely, and they're being completed very aggressively. So there are risks that the wells communicate and that the wells talk to each other. And when that happens, wells drilled in the future may not be as large because they've been drilled into pressure sinks. Right? This is a big, big issue. It's called the parent-child well issue. So as good analysts at WoodMac, we modeled all of this to the nth degree, and I will not put everyone to sleep in the room with all the variables that we adjusted and all the drilling schedules that we built, but we wanted to look at this debate, this geology versus technology. And the big message here is there's lots of uncertainty into how this pans out, is our view on it. So Joe showed one of the WoodMac views that showed the Permian going to a little bit more than 5 million barrels a day. This is another way to show that. That production profile is clearly in the range that Mark showed from a lot of the research groups. But the WoodMac base view is the light blue dotted line, and that shows Permian tight oil going from just shy of 2 million barrels a day now up to about 5. Now, we modeled all these great technology enhancements that are in the hopper and that are just being used by a few of the best companies like Pioneer and XTO. Not everyone uses them yet. Everyone will, though. When that happens, what could the production profile do? So, the upside argument is that it goes to closer to 6 million barrels a day, which is the dark blue line. If you're on the other side of the debate, though, and you believe that rock is rock, and you can't out-engineer Tier 2 shale, and that the best locations have been drilled, and that the interference with wells, because we're going to drill bigger wells, very tight spacing, we're going to aggressively develop this field harder than we've ever pushed on a shale before. If you believe all those conservative viewpoints, how could the Permian pan out? And that's what we show in the red line. It's just a sensitivity. It's just a scenario. But if you believe that all these risk factors don't get overcome by technology and that they do manifest themselves, we could be in a situation where the Permian peaks in about 4 or 5 years. Now, it doesn't go down to zero. Even if you believe that conservative red line and push it all the way out to 2030, goodness gracious, it's still doing 50% more than it's doing today. But the idea is that if companies don't manage well placement and completions correctly, there's a risk that the Permian could peak sooner than a lot of folks want it to. So that was the scenario that we show in the red line, and I wanted to add that to my remarks before the debate, because it really has been a fascinating few months as an analyst after we released this paper to talk about the reasons to believe in the upside and the downside with a lot of operators and understand what they're doing to try and be more on the good side of that argument. So key takeaways for me. So globally, like the first chart I showed, U.S. tight oil, very, very competitive. The resource base is growing. It's continuing to grow. The Permian is fantastic today. Watch it over the next few years, though, because industry is going to push on it very, very hard. So it could face a few headwinds. If that does happen, the Mid-Con assets are the ones to watch because they're the ones stepping up. They're the ones showing the biggest reductions in break-even. So we could be in a situation where there's some portfolio repositioning in about 4 or 5 years because you've got one asset class that may face some headwinds and another one that has a lot of positive potential. So those are my comments.
Rob, thanks very much. Let's just jump right into the Q&A. We've got about 20 minutes.
Because we don't have a huge amount of time for the second panel. So you can grab some coffee and come back in, but we're going to get started. Hi, I'm Sarah Ladisla. Thanks very much for being here. It's already been a really great discussion. I think Robert did a great job setting us up for what we're going to talk about in this panel and why talking about the Scoop and Stack and the Anadarko Basin is of particular interest right now. I want to just really quickly introduce the excellent speakers for this panel so that we can get underway and save some time for additional discussion at the end of this panel. First, we've got Deborah Higley, who's a research geologist at the U.S. Geological Survey. It's Deborah's first time here to CSIS, so we're really pleased that she could make time to be with us today, so thank you. And then we're going to go to John Staub, who's the Director of Petroleum and Natural Gas Analysis at the U.S. Energy Information Administration, clearly one of our favorite organizations. We keep collecting your alumni. And John and I actually started off at DOE around the same time when we were younger and just got to think about things all the time and didn't have to manage anything, and that was fun. So John, thanks for coming and being here today. And then finally, we have Stephen Ingram, who's the Vice President for Technology Solutions and Innovation at North American Operations in Halliburton. And Stephen, this is your second time here. So you were here not too long ago for a conference that we did on environmental impacts of U.S. tight oil development. And it couldn't have been too bad because you came back. So we appreciate you being here today. So we're going to start with Deborah, who's going to talk a bit about geology, and then John's going to talk about some of the really excellent work that they're doing at EIA, analyzing different plays in onshore production, which there's a number of you here, John Conti, Alulu, the James Bond of energy. You can ask him what that means. You've been doing some really great work on this, so we'll talk about your analytical perspective on those basins, and then Stephen, from your perspective, what you're actually seeing out there in the field. So without further ado, Deborah, please take it away.
Good morning. I'm going to discuss some of the background geology, since John will be talking about more about the numbers, the forecasts, and things of that nature. So what the images on the screen is part of a four-dimensional model we built for the basin. I'll go into that in a little detail. The U.S. Geological Survey has a congressional mandate to assess onshore United States and world oil and gas resources. We do that using a total petroleum system methodology, and the methodology, the publications, raw data, GIS data, including all of the grids that were used to build a 4D model, are all accessible from our energy.usgs.gov website. So the various slides I'm going to be presenting are also available on that site, mostly from a USGS digital data series 69EE, which is about 330 pages and multiple appendices, and it's great if you have an insomnia problem, but some of it's interesting. What we assess are resources. We don't assess the reserves. We don't assess what is left to be discovered from actual producing wells, from existing fields. We assess what is left to be discovered, both from continuous, also known as unconventional, and from continuous, also known as unconventional, and also from conventional reservoirs. Conventional is much of the historic production. It's from structurally trapped oil and gas, the more stratigraphically trapped against permeable barriers, changes in lithologies, and other geologic factors. So the focus has been on unconventional, and that's the current focus of the USGS. So I'm going to just be presenting a lot of the unconventional information. Even though much of the Mississippian, much of the stack is more considered conventional, it is a bit of a mix. So the Anadarko Basin was last assessed for undiscovered resources from the Cambrian all the way up into the Permian in 2011. So much of the scoop and stack play in province has actually been since then. So I'm going to show you a little bit on how that's evolved through time. So this shows the mean unconventional gas resources for basins that have been assessed from 2000 to 2017 for the onshore U.S. I'm just going to show you the unconventional for oil and for gas. The conventional is also on our website. So it shows the big basins. That the Anadarko Basin, we assessed mean unconventional gas resources of about 25 trillion cubic feet of gas. This is a very mature basin. There's more than 300,000 wells that have been drilled. And that said, there are still a lot of areas that are very underexplored for the Anadarko Basin, including the Scoop Stack area, are underdeveloped for various geologic reasons. A lot of people compare the Anadarko Basin to at least the Woodford, to the Bakken, and some to the Wolfcamp, but actually has a lot of similarities to the Marcellus. So for oil resources, Anadarko is mostly a gas basin, but it has the advantages of having oil, natural gas liquids, and gas, and you have multiple potential producing horizons. A lot of the conventional drilling and production has been from vertical wells. So if someone is drilling down and happens to see a nice juicy show somewhere, they have a lot of downwell potential. In the last few years, most of the drilling and almost pretty much all of the unconventional has been horizontal wells, and that's made a huge difference. So the little yellow line, the one that has the little nose there, it's the Woodford Shale. That is the mean undiscovered of 18 trillion cubic feet of gas, 192 million barrels natural gas liquids, and 393 million barrels of oil. A lot of the Scoop area is that little sort of oval-shaped blue infill area within the Anadarko Basin in Oklahoma, Kansas, southeastern Colorado. In that particular assessment unit, we use a total petroleum system for an area for which has a common hydrocarbon source rock, mostly the black shales. But within that source, which is, in this case is mostly the Woodford Shale, you can have multiple producing horizons that have significant geologic pressure, geophysical characteristics. We call those assessment units. We have them at the 5 to 95% confidence level. So if you want to see how good our starting data we use, how sure we are of our assessments, you look at the 5 to the 95% range. We report the mean values, but if you have a very broad range of 5 to 95, there's a lot of uncertainty. If it's very close, we have a lot better data. The Marcellus, by comparison to the yellow line for the Woodford, is a much, much larger area that was also assessed in 2011, and that was assessed at 84 trillion cubic feet of gas and 3379 million barrels of natural gas liquids. The Marcellus is currently being reassessed, which will be done within the next year or two. This is called a cut cube view. This is a view of the 4D model, and it's looking towards the west. Kansas is on the right, Oklahoma is on the left. But much of the Scoop area is within the area that's cut out, the area that's just to the right, just this side of Oklahoma. This shows the basal part of it is the Precambrian, the top of the Precambrian. That broad green zone, that is the Mississippian layer. So that includes all of the Mississippian. Lateral changes in colors are differences in lithophases, going from different percentages of sand, shale, siltstone, carbonate, limestone, dolomite. A lot of different variables factor in on these four-dimensional models. So the Mississippian layer that makes up a lot of the stack area is fairly thick in the deep basin, up to, well, it's thousands of feet thick in the deep basin. Once you get into the shallow platform area of Kansas, you're looking at a few hundred to 1,000 feet thick mostly. This is the Woodford Shale. This is the isopac of the Woodford Shale. So the brownish, tannish contours that it looks a little bit like a large slug with, that's actually the basal Mississippian Woodford Shale overlies the unconformably well, the Woodford Shale, or the Hunton Group underneath is mostly Silurian. After the Hunton Group was eroded, you have these different distributary channels that were eroded in it. Those make up the thickest section of the Woodford Shale. This is a very rich petroleum source rock. Those channels have both the thickest intervals and the best quality of source rock. That's one reason why the oil in red, or the oil in dark blue, and the gas in red is concentrated along a trend that's an arcuate trend that is filled in some since this. There are a number of different horizons, intervals within this. The Sooner Trend area that's shown in the blue outline is actually much larger than that. That was an original Sooner and Ringwood trends. Those have since expanded. That essentially these areas were the Mississippian best production for the Merrimacian and the Osagian have extended into Kansas. The Watauga-Chickasha trend, which is it's a shallow, or it's a subtle structure, it's rather like a large anticline. That's has a lot of importance to Pennsylvanian production, and it also forms a barrier for overpressure. Much of the overpressure for the Woodford Shale to the Des Moines section is within and to the west of the Watauga-Chickasha trend. The cement field is just to the west of the Golden trend. You have a lot of basement floored faults within the basin, and that particular structure actually get production from Cambrian through much of the Pennsylvanian. So you have 200 million years worth of rocks you can potentially frack and produce from. So even though there have been several hundred thousand, more than 300,000 wells drilled in this basin, there's still a lot of areas that are underexplored, particularly in the Sooner Trend area. This shows the Mississippian gas. The multicolored wells are from up until 2000. So that represents the end of our assessment of the Mississippian. There's a somewhat almond-shaped area where you have the Ringwood Sooner Trend. That was almost completely unexplored for oil and gas from the Mississippian during our assessment. That's one of the reasons we go back through and reassess basins, is because you have gaps that you have very heterogeneous, slightly underpressured limestone, packstone, waxstone, sponge spicules, and a lot of other funky names for these intervals. They were hard to produce from vertically, but much easier to produce from horizontally. The area with the big pink dots, that just represents the production from 2010 to 2013. The area's filled in a bit more sense, but there's still a lot of area that's missing. This is oil. So you have oil, gas, natural gas liquids from the scoop, and the stack areas also more or less corresponds. Also in the deep basin, that purple outline that's somewhat indented, that is the Woodford Shale Gas Assessment Unit. If you look at the wells within that, they tend to be linear, trending to the northwest. A lot of that is structurally trapped oil and gas. A lot of the stratigraphic traps in the deep basin, they're less well explored. It's a lot deeper wells, so a lot more expensive to drill, and it's also natural gas, which is a lot less focus right now. This is from Higley 2016, which is also on the energy.usgs.gov website. So the area in gray represents the extent of the basal Pennsylvanian, the Morrowan, the Morrow sand, which is a big producer in the Anadarko Basin. It's also the eastern limit of the uppermost Mississippian, the Springer and the Chester intervals, which a lot of conventional oil and gas in the basin. So much of the Sooner Trend, that white triangle, that's within the eastern portion of Oklahoma on this. That is a Sooner trend, part of the stack trend, and a lot of that is, well, it's underexplored. It's also normally underpressured, was also a factor on why it has not been explored and developed in the past. I'm not going to go into detail on this because I don't want to take up too much time. 3 minutes. So this just shows when we create the models, we calibrate it against a lot of variables: temperature, pressure, vitrinite reflectance. This area in yellow to the pink line, that shows the area that's thermally mature for oil generation from the Woodford Shale. This is the top of the Woodford Shale. It's part of the 3D model. I'm going to go through a quick animation. The areas that are blue to purple, the colored intervals represent the beginning to the end of oil generation. And there will be green lines here. The green blobs show areas in which oil has flowed through. So the basin will drop down through time. It'll be brought up. It also tilts. It's been a very active basin. It's gotten a lot of exercise. 300 million years ago, started the Woodford Shale transformation ratio. So 280, 260. This is top of the Mississippian. So this shows oil flowing on the Mississippian. The area just below the north arrow and to the right of it is the Sooner trend. You have a massive flood of hydrocarbons, of gas and oil flowing through that area, partly because that is the area where the Woodford Shale is thicker, and also subsurface topography has also driven the migration. 200, 180, 160, 140. We have laramide orogeny about 60 million years ago that has also tilted the basin slightly, which has probably resulted in some remigration of oil. So you have a very long period of oil and gas generation, migration, and trapping within the basin, and a lot of intervals that are underexplored. So this is what top view of what the migration looks like, with the pink dot areas, the stack and somewhat of the scoop area. And this is in black as the existing wells as of through 2010. So there are a number of different factors as to why the scoop and stack are such an important. It's underexplored. You have multiple stacked horizons: the Merrimacian, the Osage, the Mississippi Lime, informal name. You have it proximal and up dip of overpressured area. So even though that's a little tougher to find when you're exploring from the oil and gas generation, it's very important because it means that you have the flood of hydrocarbons as the oil and gas are trying to find a less pressured environment to live in. You have multiple traps, multiple stacked traps, and those are just some of the factors as to why scoop and stack are such important areas for exploration and development.
That's great. Thank you very much. Okay, we're going to move on to John. I think there may be a couple extras to go. There you go.
Oops. Great. Thank you. So when I was asked to speak, one of the questions was, why did EIA add the Anadarko region to the drilling productivity recently? And as has been discussed already, there's been quite a bit of activity. It's a basin that's had a long history of production. And when we looked at the data, and I'll show it just briefly, we've seen production of gas fairly significantly in our shale gas slides for a long period of time. And one of our questions that we've been wrestling with is on the oil side in terms of how much potential there is for oil production in that region. We've seen a lot of growth just here in 2017, about 25% production increase on the oil side, going from about 400,000 barrels a day to 500,000 barrels a day from December of 16 to December of 17. When we look at some of the formation names and the reservoir names, we see that a majority of the new wells that have come on in the last year and a half are Mississippian named, followed by Woodford and Mississippi Lime. The challenge with the data in Oklahoma is that the naming conventions and the misspellings that occur at the well level detail is kind of diverse, I guess might be a nice way to say it. And so that makes it challenging to figure out, is it just the old rock that they're going after with different types of wells or orientating the wells differently, or is it a new piece of rock that we're not familiar with? And so that's been a challenge to understand just how large this basin is in terms of its production potential. I guess I'll just keep moving on from there. So the graph on the right-hand side shows the Woodford shale gas kind of down lower part down there around the 6 on the far right-hand axis. So you can see the significance of the Woodford over time. It started relatively early. If you're grouping all of the production from wells that are identified as Woodford type formation names. It's hard to see the Woodford and the Granite Wash on the left-hand graph with the tight oil. It's relatively small. This is a chart showing new wells that are, so most of the data that I'm going to present is from Drilling Info. So it's state administrative data that's been collected by Drilling Info. They've done some cleaning, we've done some cleaning to try to group information together. And so these are wells that had their first production in either 2016 or 2017. And you can see that 624 of those wells had the Mississippian formation name or reservoir name, followed by Woodford, just under 400, and then Mississippi Lime, et cetera. You can see that wells that are identified as Springer, you can't really see it. If you squint real hard, you can see it's kind of in the mix of everything there. And Granite Wash is also quite small right now. When we then look at production, and so what these graphs here are showing is production. Blue is, and there's several of these charts that I'll have. Blue is for gas, green is for oil. For particular reservoir names, formation names in red. And then they're ranked, and this is just production within Oklahoma. They've been ranked by the first 3 months of 3 months of production. So the first month is a partial month, and then the second month is a full month, and then the third month. And so we've summed up the oil and gas, so these are barrels of oil equivalent, to rank the formation. So the Woodford actually has a higher volume of production than the Mississippian, mainly because of the gas. You can see in the vertical axes are not the same on all these charts. So there's a tremendous amount of gas coming out of the Woodford relative to the Mississippian, about 3 times as much. But you can see that there's been a fairly steady increase in oil production from both of these formations. It's maybe a little bit flat in the recent data from the Woodford, but the challenge is it just reporting delays that we're not seeing the most recent data. When you look at the Mississippi Lime on the left, that has not been as strong in the recent years, which is along the Kansas-Oklahoma border primarily. And then the Desmonian includes a number of reservoir names that we've grouped together just for trying to collect things. And that also has actually been pretty flat on the oil side, maybe declining and declining on gas. The Springer, you can see the relatively recent increase, and it's fairly substantial, getting up to roughly 20,000 barrels a day of oil, but the gas declining there, and then the Granite Wash also relatively weak in recent years. This chart here shows for those wells that started producing in 2016 and 17 in the data, a majority of them are horizontal wells and less on the vertical. And same wells in terms of formation reservoir, you see how the Woodford is a bit more to the south in Grady and Canadian counties, while the Mississippian predominantly is in the Kingfisher and Blaine counties. Mississippi lime is scattered more towards the north. Of course, a number of wells are either in other formations or not yet identified. And so then if you add up the production from these wells, you see how Kingfisher County, which is where the stack is leading production, followed by Blaine, Canadian, Grady. So there's definitely a core area there in the production for liquids. And then for gas, you see generally the same formations, but in addition you see Hughes, Pittsburgh counties on to the east that also have quite a bit of gas production. This is from our drilling productivity analysis, and when you shift the WTI price relative to the rigs, you see that rigs follow on a roughly 4-month lag to WTI prices, and in the Anadarko region, it appears to be a bit more sensitive than it has been on the national level to movements in price. So there is, would suggest to me that prices are a little bit more important to the Anadarko in terms of accelerating or decelerating activity in that region. We have seen growth in initial productivity per well. It's the data for 2017 is pretty sparse at this point, and so that's part of the reason you see that uptick on the tail of that line. So I wouldn't read too much into that, but the growth that we saw from 14 to 15 to 16. It appears to be slowing in terms of initial production per well, and so that's a question of how much more production or how widespread this production can be across all the wells that are being drilled. The rig productivity, which is the kind of main indices that the drilling productivity report focuses on, sees continued improvements, but it's quite shallow in terms of that growth of rig productivity at this point. Some of the inflection points that you see in the rig productivity index are related to shifts from core to non-core areas and back as prices move. So sometimes you have to think a little bit about what are all the events that are going on in the marketplace, and not just look at the index, productivity index, and say, oh, that's absolute measure of productivity. These two charts show oil on the left and gas on the right on a relative BTU basis or equivalent basis, and so you see how in the Anadarko region gas has been and continues to be a more significant part of the production. Certainly the oil production has grown since 2010 and then declined a bit following the drop in prices, but we do see growth through the end of this year. I like this chart because it helps you think about just how drilling these shale and tight wells is this manufacturing process that was talked about earlier. In particular, if you look at the right-hand light blue section, which is new wells for our going out from August of this year through the end of 2018, you see kind of how significant amount of production growth is going to be coming from these new wells. So they'll be producing 300,000 barrels a day of oil by December of 2018, just from those new wells that are going to be drilled in our forecast. The declines from the older wells are more shallow because they've already gone through that initial phase of steep declines in the first year or two. The graph on the right shows our outlook for the Anadarko in red. So you see December values for 2016, 17, and 18 growing from 400,000 barrels a day in 2016 to about 500,000 barrels a day for both 17 and 18. Based upon the price forecast that we have in our short-term outlook and the activity that we see in terms of numbers of rigs and the productivity at the well level from the data that we have in drilling info, we just don't see a lot of additional growth in the next year. So that's why I'm especially happy to be here to hear from others and discuss what is the potential of this number being higher, lower, or relatively the same. And I think that's all I have. And just wanted to acknowledge Danya Morelli, who's sitting over here on the right-hand side. She's one of our lead analysts working on the short-term energy outlook and all of this analysis. Thank you.
Great, thanks. You get an extra dessert because you were like a minute early. All right, go ahead, Stephen.
Thank you. I was lucky enough, and I appreciate the opportunity to be here. I started as a hydraulic fracturing engineer in Oklahoma. I worked as a technical advisor and hydraulic fracturing engineer in this area for many years. No problem. So it's always good to talk about Oklahoma. Oklahoma is a cornerstone for Halliburton Company. We've been operating in there since the late 19-teens and through the 1920s. So it's been a core part of our business for a long time. You really can't talk about any one area without talking about them all. So there's a little bit area. The reason I have this chart up here is to talk about a couple of points. One, there's an awful lot of rigs operating in North America today, but more importantly, there's an awful lot of active oil and gas operators. This is an amazing group of entrepreneurs. So there's 401 active United States oil and gas operators as of a few days ago. 59% of those operators have a single drilling rig operating. Single rig. It is an amazing group to try to herd. It's like herding cats. In terms of the mid-continent business and obviously the nomenclature issues and challenging, having been from there, I laugh. There's an awful lot of secrecy that oil and gas operators play with naming conventions in the greater Oklahoma mid-continent area. A lot of it has to do with leasing and not leasing and selling and M&A and transacting and swapping acreage. And so they like to use an awful lot of names and be innovative with names. And also all nomenclature changes as soon as you move across the Oklahoma border into Texas in the Panhandle. So the granite wash goes from being talked about geologically to being talked about in terms of colors, for example. Mid-Con has 124 active rigs as of a little while ago, so relative to the Bakken, it's well in excess of twice the size of active operations. Relative to the DJ, it's about 5 times the active size. Obviously small compared to the Permian, but it's the largest individual play relative to the rest. So that is the scoop and stack, but it's also many other plays. So it's a very active, ongoing environment. I like to just to say relative to where we are, and I won't speak about the boom and bust of where we are, but relative to downturns, 5 years after the peak activity, where are we? You know, kind of we're in the middle of the worst, and still many of us are suffering kind of through it. And while activity has come back quite a bit, there's a lot of stress that's there. We'll be interested to see how activity plays out in the years to come. A lot of people ask about DUCs and drilled unconventional wells. 2 clear nomenclatures about this. One is wells that are clearly deferred by choice of operator to not spend money on that production and push it into some period later. And then there's the normal working inventory. And as you can see, as we get to more and more pad wells, there's more and more normal working across North America. So more and more normal working, and we expect that to grow. So that gray bar, we expect that to grow relative to total DUCs, assuming a continuous commodity price level for both natural gas and oil. So the Anadarko. So very, very active. Many formations in progress in each of those two particular provinces. So the primary activities today, Oswego, Merrimack, Osage, and Woodford, are all being actively developed today. In the SCOOP, it's really lower and upper Woodford. There's been about 4,000 horizontal wells completed in these basins. Vertical depths today are as deep as about 15,000, although there's a couple permitted deeper than that, but they actually haven't spudded. There's room to be optimistic about the Permian, about the Mid-Continent business in general. I'll speak a little bit about that and where those might be. These are the active developments. We've been playing around in all of these formations in some form of today's convention, meaning horizontal multi-stage fracturing, for the last 15 years. So you've got the Scoop and Stack, but you also have the Cana Woodford. That was developed primarily by Devon and Chesapeake in years gone by. Horizontal Granite Wash is now, for the most part, entirely held by production, so only economic rationale would drive activity. And again, almost everybody who has Granite Wash acreage holds acreage in the Scoop and Stack and or other basins across. And so they may have rig and or other contractual commitments to drive their capital outside of those basins. Granite Wash, as a horizontal play, both in Texas and Oklahoma, has substantial fairway in the future. You've got the rest of them. The rest of these all hold true and all similar rationales as to why or why not investment may or may not be going on in any of these. We're beginning to see the uptick of the Arkoma Woodford in southeastern Oklahoma. This was heavily developed in years 2006 through 2011 by BP, Newfield, XTO, and a number of other companies in the area, Hughes County, Cole County. There was a question earlier around the parent-child interaction. The first time as Halliburton Company saw this as an issue and or a challenge to be solved was 2006, 2007 in Hughes County, Oklahoma, with Devon Energy on 3 well pads coming in to develop after they had held production with 1 well per section. So the aspect of parent-child interaction and depletion through tight gas has been, and there are many papers written about that by both them and us in that time frame. Kind of from a perspective today, obviously there's a lot of Scoop and Stack development going on right now. We service this primarily out of Duncan and El Reno, which are our 2 facilities. Sand and sand distribution is key here, as it is in all. So we now own and operate sand distribution. I'll have a picture a little bit later, directly across the street from El Reno. So if you're ever on Old Route 66, driving west of Oklahoma City, you can wave at our facility. It's right off the highway. When I say 15,000 employees, this is how many we have hired in the state of Oklahoma since January. So we have hired this many employees to service the growth in the Scoop and Stack development. We service this business with 13 different product lines or business lines, and it's one of our active, and it is our oldest. We've been operating in the greater Oklahoma area since we were pre-incorporated. So we are actually incorporated in 1923, but we were servicing this area. After this, we got to Texas as soon as we possibly could. So we've been operating in the Permian since 1935. Talk a little bit about why. The Cana Field was a very interesting play. So after the Barnett Renaissance, the Woodford Shale in southeastern Oklahoma was the very first Oklahoma shale play to really, in earnest, be developed. And it was developed for many, many years, and it was quite a lucrative gas play when gas prices traded high in the $5, $6, $7 range. A number of activities that were treated there. The next one that came up after that was the Cana Woodford. So Cana Woodford was developed, explored, and developed as a horizontal multi-stage fracturing operation and by a couple of operators who had legacy acreage. So they already owned the acreage. They were going after deep channel sandstones, the Springer Formation, Hunt and Lime, other ones. And you can see that on the graph or the image, kind of see physically how deep and big it was. And this was a big play with lots of press releases, very important to a number of operators. And then you can see why people are quite excited about the SCOOP. So some of the Oklahoma area oil and gas operators, both in Tulsa and Oklahoma City, were unable to obtain acreage in the Cane of Woodford, so they saw lots of their direct competitive oil and gas operators doing a lot of very good things. The Scoop and Stack has provided them the opportunity to explore and develop there in their backyard. The Scoop and Stack is not entirely, but primarily developed by local Oklahoma-based oil and gas operators. There are some with investment from outside, but mostly it's local. And that's because the greater Oklahoma area has been explored and developed, as was said, for so many years with so many hundreds of thousands of wells. So there is deep knowledge of the area, the capability, and lots of M&A that's happened over decades related to acreage positions. The thing that we're probably most excited about as an industry is the thickness and that bottom aspect, which is the original oil in place. I tend to believe that original oil in place predictions are typically conservative in nature, as I imagine everybody would agree. But those two in bold in terms of thickness and oil in place are why people are so excited about this. I wanted to throw up here a couple of recent completions. What does a typical hydraulic fracture stage look like in this particular area? So I have 3 of these. So typically, people are developing multi-stage pads now. For the most part, acreage is held by production, but not entirely. And so the actual project looks like the image represented on the right. So each one of the little tick marks represents a hydraulic fracturing stage, and then the bullet points represent what that might be. So the Scoop Lower Woodford is typically unconventional nanodarcy permeability, as previously discussed. Typically today they're being produced off of a 10,000-foot lateral with TVDs on average around 14,600 feet. Total measured depth of the wellbore is about 25,000 foot. That's a typical well in this area today. 5.5-inch casing. This is strong casing for handling significant pressures while treating. This is some of, outside of the Haynesville Shale or the ultra-deep Utica, this is some of the hardest onshore U.S. Hydraulic fracturing done in America today. So this is right up there. Typically 40 plus or minus stages, 500,000 pounds of proppant per stage, around 750 to 800,000 gallons per stage, 80 barrels a minute, and as it goes on. Treating pressures 10.5, but they do get up as high as 14,000 PSI. Obviously 14,000 PSI wrecks frac crews, so we try to work on those designs. In the stack, it's kind of stack and what formation, so it's not just a stack, so stack Merrimack. Much more of a conventional zone, also as discussed. So when you start to get to these type of porosities and permeabilities where you're not in the nanodarcy range, you start to have some design considerations. Not all of these are treated with slick water, as is the primary treatment in other areas. When you have actual formation leak off, and then you have to start to get to some other aspects during the treatment. Again, 10,000-foot laterals are pretty normal today. Measured depths around 23,000 feet. More stages per lateral. Obviously, you now start to have design changes in the actual fracture treatment. You've got more stages, closer stage spacing, smaller stages in terms of size in order to extract the most amount of value. They tend to drain quite well. Still high rates and pressures and fairly high frac gradient. The stacked Osage, a little bit different again. So today, earlier time period, about 5,000-foot laterals. You have about 5.5-inch, not quite as strong casing. About 25 stages for those 5,000, so you can do the math on terms of stage spacing. Smaller stages or smaller proppant, but in terms of pounds per foot, these are quite conservative at this particular time. A lot of this, again, has to do with the system permeability. So the actual reservoir has the ability to more radial drain or bimodal drain into the hydraulic fracturing system itself and produce. So typically, as you get better system permeability, the amount of hydraulic fracturing needed and proppant volumes required are less. Not quite linear, but less. So kind of the opportunities inside of the Anadarko Basin as we see it, kind of representing a service company that proud to be a service company supporting this area. So we see an expansion in the Arkoma-Woodford Basin. That's primarily natural gas, but again, as talked about in terms of private equity money, we see private equity money going into that area right now. We also see BP moving in lockstep into that area as they continue to form out a presence again onshore U.S. Continued step-out appraisal. Obviously, we talked about underinvestment, under-exploration. So step-out appraisal is going on right now in a number of science wells. Infill development, we talked about the fact that, and as we've talked about, staggering and or stacking wells and in which area. So that will become a part of this area more intensely than it has this year and in years previous. Lots of optimization efforts, which will either increase the productive nature of each well and or will lower the cost. Hopefully it will do both. Oklahoma already has excellent infrastructure on the backs of oil and gas development and other developments in years past. So infrastructure for a service company, meaning road, rail, and water. You have increasing connection to pipe or to the market. So increasing pipeline capacity is building out. But I would say that it is just like the Permian Basin. It's one of the constraints to growth. We have a very supportive and knowledgeable community in the greater Oklahoma area. So this is not their first oil field. They know and understand. It's also not their first unconventional oil field. So they know and understand, and in the regulatory and political environment knows and understands what is being asked of it as every new basin comes online. It's highly competitive, and what I mean by that, it's highly competitive from a large volume of operators that are operating the basin. So from a service company, that's very good for us, provides us the opportunity to have a diversified portfolio of clientele. And there's also a very mature supply. Oklahoma is an area where there's actually a lot of manufacturing that goes on for oil and gas onshore, from the development of trucks, trailers, pumps, packers, equipment, et cetera, so it's readily available right there. There's also a large number of competitive service companies, which is good for oil and gas operators there. They have a lot of choices, so it keeps us honest. So really, that's the kind of the quick what we're seeing right now. Great play. We've invested in it. We continue to invest in it. And during the downturn, it was actually one of our areas of largest investment, second largest area to the Permian Basin. So, thank you.
Perfect. Thank you. Everybody was on time. You all get extra dessert. So we've got 25 minutes for conversation. I'll take questions, and maybe just to start, I have two questions, and it kind of brings in the last discussion too, so Mark and Joe, if you wanted to answer as well. But
start with the rock, talk about the geology, talk about the infrastructure, talk about the cost-price issues, and figure out what the profiles look like. It was about resources, but what the production profile looks like. As you look in the global market, where does this crude oil go? What does it take to get there? What's it competing against? And my go-to guy on a lot of this infrastructure for the last several years since we first met has been Rusty Brazil. Rusty's the president of RBN Energy down in Houston. He has a long industry background as well. Terrific and animated analyst. But he's going to take us through some of the challenges. So connecting the dots. Adam and I were talking about this morning about how much information and data is out there now. But if you don't put it in context, you don't understand the complexity of the system and where it's going. And Rusty is one of the best people I know that does that for us. So we're going to walk through an animated slide presentation and then leave ample time for questions and answers. But thank you all for joining us. And Rusty, the floor is yours.
All right. Well, thanks, Frank. And the reason I'm sitting down here is because the slide is sort of the entertainment thing here, if you will, and these things have a lot of clicks on them. And if I was looking over there, then I'd be looking over everybody's shoulder during this whole presentation. So we've been talking all day about how much production is coming on, and it's great news for producers, and it's great news for consumers, and great news for the market in general. But it only makes sense if you can get the stuff to a market and sell it and make money because you do it. And so that's what I'm going to be trying to address here today is the infrastructure side of things, because if you don't have the right infrastructure, then bad things happen. Either I either I have to shut back my production, I have to deal with very low prices because of price differentials that develop because of takeaway capacity constraints, or all sorts of other issues that make things complicated. So that's what I'm going to be discussing here. Let's see if I can make this work. Yep. But this is Frank's favorite slide that I do, so I didn't want to go through this presentation without hitting it. And I think it does kind of make the point that, wow, what we're seeing right now is something that I know we didn't think we'd ever see in our careers. This is crude oil. Crude oil production over since 2006 got up to 9.6 million barrels a day, dropped down to 8.6 million barrels a day. We can see what's going on now. We are back up to where we were when crude oil prices dropped. So in other words, that's a recovery, right? And you can see what happened with the hurricanes there, with the two dips on the hurricanes. Just a blip, didn't matter. Production is up, and if you can see that red line that's there on the slide, the red line is the Permian. So like we've been talking about all day, the Permian's driving a lot of this. So we're not up to all-time record volumes yet. We're not back up to 10 million barrels a day, but we are dangerously close to it. We are at all-time records for dry natural gas in the lower 48. We got up to about 74 BCF back in 2015, dropped off not only because of pipeline capacity constraints getting out of the Northeast, but also because of associated gas dropping off as crude oil was dropping off in that slide immediately to the left. But as crude oil production came back on and as pipeline constraints out of the Northeast, Marcellus and Utica were relieved, we're now up above 75 BCF. And somehow or another that gas is all finding its way to a market, and it looks like it's going a lot higher as new pipeline capacity comes online, mostly in the Marcellus Utica. And as you can see there in that purple line there, it's the Marcellus and Utica that's driving a whole lot of that trajectory. Then there's my favorite product, NGLs. I'm not going to talk much about NGLs this afternoon, but NGLs didn't even see the blip, right? There's not even a blip there. It's going up faster than the other two commodity markets. It's going to continue to, not only because it's going to be more wet gas coming from the growing production for wet natural gas in the United States, but also because there's a lot of ethane that's currently getting rejected. It's not going to be rejected anymore in about another 18 months because of a lot of new petrochemical plants coming online. So natural gas liquids production is going to be the fastest growing commodity market in the United States. Going back to crude oil, this is, Mark actually showed, I guess, kind of a version of this. Bakken was up to like 1.2 million barrels a day. When prices crashed, got down to back down to about 1 million barrels a day, and has been eking back up just slightly, but not growing like crazy. Eagle Ford was the fastest growing basin in the country, fell off, was the fastest declining basin in the country, and is again eking its way back, but not growing like crazy. There's the Niobrara and the Anadarko combined. So in the Anadarko, that's where Scoop and Stack is. And we'll be talking more about Scoop and Stack a little bit later. What you can see there is that those volumes fell off after crude oil prices crashed about 20%. Now we're back up to right where we were before. But, you know, the rest of the story, all right, there's the Permian. So there's nothing else I can say about the Permian besides what we've already talked about. It's just up and to the right, and it's going to stay up and to the right for as far out as we do forecasts. One of the things that is going on in the market right now, and one of the implications of this whole infrastructure issue has been discussed a little bit so far today, and that is this relationship between West Texas Intermediate and Brent. And I've added also Light Louisiana Sweet, LLS, there too, because it is representative of prices on the Gulf Coast. So we're going to talk about infrastructure. Infrastructure always has implications for price differentials. So those price differentials we'll talk a little bit about here. There's the thing that everybody always discusses, Brent versus WTI. And the places that we're talking about here down, for just to get everybody oriented on the geography, WTI Cushing, right in the middle of Oklahoma, right next to Scoop and Stack, by the way. LLS down on the Gulf Coast. There's other crudes down on the Gulf Coast too, but LLS is a good marker. And then Brent in Europe and the UK. So what happened to that differential? Back in the good old days, back in $100 crude oil, back when there were pipeline capacity constraints going out of the Cushing area, that differential got all the way up to $25 a barrel. And at that point in time, there was a great motivation for midstream companies to build pipelines, and they did. One of the things that, if you note, though, that differential, although it says it's Brent versus WTI, it wasn't Brent versus Gulf Coast crudes. The difference between Gulf Coast crudes and Brent was basically zero, like about 8 cents or so. So the differential was really that green arrow that you see there, the green arrow between Cushing and the Gulf Coast, not the blue arrow going from LLS to Brent. And that's an important fact, because when new pipelines, Seaway and Trans-Canada MarketLink, were built down to the Gulf Coast, what happened, the differential collapsed all the way down to averaging about $2 for that period of time between 2015 and about 6 months ago. So let's zero in on the time frame over the last couple of years and talk about how that relates to infrastructure. That's the blow up of Brent versus WTI. In the first half of 2016, down to $1.52, up to $1.71 in the last half of 2016. That was extremely bad news for companies that had paid for capacity to move crude oil from Cushing, Oklahoma to the Gulf Coast on pipelines like Seaway, and were paying $3 for that capacity during that period, because the differential between that period was only about $1.50, $1.70. By the time we got to the first part of this year, we're up to $2.68. So things are looking good, and then all of a sudden, bam, we're up to over $6, average for the last 5 months right at $5. And so the world has really changed in the last 6 months. There's a lot of reasons that have been given for that. The hurricane, what OPEC has done, the shakeup in the Saudi house, you name it. There's a lot of reasons been given for that. I'm going to submit to you that it's mostly about infrastructure. But because I'm here and because we kind of have a warm spot in our hearts about this, we just have to talk about the fact that crude oil exports now are 1.6 million barrels a day on average. And the reason this is a warm spot in our hearts is because we kind of kicked this whole, I like to think we kind of kicked this whole issue off in 2013 and maybe had a tiny, tiny bit to do with the fact that, and Scott Sheffield, by the way, had more than a tiny bit to do with this as well at Pioneer, and there are a lot of other folks too. But maybe we had just a little bit to do with the whole export ban getting removed, and now that we're up to 1.52 million barrels a day getting exported, I think that is a wonderful story, not only what it means for being able to balance the quality of crude oil out within the United States, but just the fact that this crude is going to international markets, which to me gives us that much more stroke in international markets than we had before, because it's real USA barrels going that way. So let's talk about what's happening now. What's happening to that differential? There are two sources of crude that we've talked about so far, and one is the huge growth in the Permian. The other is the growth around Scoop and Stack, and again, Scoop and Stack is right next door to Cushing, Oklahoma. Cushing, Oklahoma being the primary location where all the barrels were aggregated before, where that big differential was before, and all of the barrels from both Cushing and Permian, most want to go to the same place. They want to go to the Gulf Coast. They want to go to Corpus. They want to go to Houston. They want to go to St. James. And so if all of that crude oil wants to get to those marketplaces, what is the likelihood of those pipelines actually getting full? Well, there is a likelihood to that. When you look at the differentials, it's very similar to what it was 5 years ago. There is no differential between Gulf Coast crudes and Brent crude. It's flat. The differential that's emerged in the last 6 months is the differential between WTI and LLS, the differential between Cushing, Oklahoma, and crude oil on the Gulf Coast. No matter what flavor of crude oil on the Gulf Coast, that differential has emerged. That relationship you see there on that graphic is a clue to us that what we're dealing with is a bottleneck. Now, as you know, I make a lot of these presentations in the state of Texas, and so I have to have a metaphor that resonates with people in the state of Texas as to what a bottleneck is. In the state of Texas, this is a bottleneck. Those are little tiny barrels of crude oil in there, if you were wondering what that is. So there's something going on here. There's a constraint going on not only from Cushing, but also from the Permian in getting barrels down into the Gulf Coast, where 50% of the refinery capacity of the United States is located, and where where all the exports are going out of. The barrels want to get to the Gulf Coast so they can get in refineries, so they can get on boats. And we've got an indication here in that graph to the left that something must be clogged up. So let's see if we can figure out what's being clogged up from both directions, starting with the Permian. And when we start with the Permian, we're going to start with a history lesson. We're going to go back and look and see what the Permian was like back in the olden days. The olden days being defined as 2005, 2009. Back in those days, crude oil production out of the Permian was about 900,000 barrels a day. It was flat as a pancake, not growing, nobody cared. What was the statement? It was the largest unprofitable basin in the country. I thought that was great. I'll use that. And that is the differential between the Permian WTI, West Texas Intermediate. Remember, West Texas Intermediate comes from the Permian, right? That's the reason they call it West Texas Intermediate, even though it's mostly sold at Cushing. The differential between Permian crude oil and crude oil at Cushing was essentially zero. Then we get to 2012, 2013, 2011, I guess, and crude oil production starts taking off. What happens when crude oil production starts taking off? There's not enough capacity in order to be able to get that crude oil out of the market, and the volume is on the left-hand scale, the price differential is on the right-hand scale. And what that says is back in 2012, the differential between Permian and Cushing jumped up to about $10 a barrel or so. It stayed there for a while. There was a pipeline that was built at the time that took care of some of the problem. Didn't last for very long because production kept increasing. Then we got to 2013. Another pipeline was needed. The price differential again, because production kept rising, spiked up to almost all the way to $20 a barrel. And then 3 new pipelines were built, and that differential dropped back down to about zero, which is where it was until, well, actually where it is right now. So look at the green line there. It's an important green line. That is the 6-month average of the prices that you see there in the blue. So we're going to try to understand why that green line happened the way it did and relate that to capacity constraints. Now, there's one other thing that we need to note that's different now than the time before when we've looked at this relationship, and that is this line, wrong button, this line, which is the differential between LLS and Midland. So in other words, although the differential between Midland and Cushing is still basically zero, the differential between the Gulf Coast and Midland is now up to like $5.50 yesterday. So something, again, is going on. Let's see if we can look back and see historically what's happened in the past. That's takeaway capacity. Takeaway capacity for crude oil out of the Permian. So, you know, when you're looking at takeaway capacity, and looking at the volumes that go into that takeaway capacity, you're not worried about whether it's shale or whether it's legacy production or anything else. It's barrels. All the barrels that are there got to find a home someplace. So either it is pipeline capacity to get barrels out of the Permian, or it also includes refineries that are actually in the Permian or adjacent to the Permian that also take up some of that capacity. That is what happened to production. So if you look there very closely, there were a couple of periods where the pipeline capacity got very close to, or the production got very close to the pipeline capacity. And if you can see there, it doesn't show up very good on this screen, but you can see that there's 2 periods there of a year or so when things really got tight. There's that green line. So in other words, really, really simple. Whenever pipeline capacity gets constrained, the differential between where it's coming from and where it's going to increases. It's always like that. It doesn't matter what the commodity is. And that makes us wonder what's going on right now. Because when we look at what is happening today, we are right back there on the ragged edge of being out of capacity. Now, Mark said before, you know, there's a couple 100,000 barrels of getting out of there. I'll be honest with you, I think that might have been the case 2 or 3 months ago. I think it's less likely today. I think we're pretty close to being right on the ragged edge. There's 2 new pipelines in the process of starting up, and so it's going to relieve that constraint. It's going to relieve that constraint when they do get started up. So it's not a problem that's going to be with us very long. But the market has responded to it. The market has responded to it not with a differential between Cushing and Midland, but with that differential between Cushing and the Midland and the Gulf Coast. That's where the differential has happened, because that's where the barrels want to go. They don't want to go to Cushing anymore. It doesn't make any sense to go to Cushing anymore like they used to 5 years ago when they're wadding away out of Cushing. Now those barrels want to go to the Gulf Coast. So the differential has emerged between those 2 locations where the barrels want to flow, and therefore we're up to a $5 differential at that point in time. This is what our forecast looks like for Permian crude oil production. So we're showing up getting to about 4 billion barrels a day. And this is not BOEs or anything like that. This is just straight, good old-fashioned crude oil barrels growing from about where we are today, somewhere around 2 some odd thousand barrels, or million barrels a day, up to about 4 million barrels a day. There's that line that we're, whoa, okay. Can you make that thing small again? I'm sure I hit some button that I wasn't supposed to hit. I don't know what I hit.
That's a very good question.
You can change the slide and see if it works, if that works. Sorry about that. Okay, I can't change slides and, oh, all right, perfect. All right, so that's where we are right now. We got several new pipeline projects that are in the process of coming on right now. So the problem is going to go away before it really starts manifesting itself in anything worse than what we're seeing so far of $5 or $6. And that manifestation is going to go away relatively quickly. Notice, though, that with the pipelines that are, at least right now, scheduled to be built, and I'll talk about those in just a few minutes, that we run out of space again sometimes in 2022. So as long as the Permian is growing, we're going to periodically run out of space, and the pipeline, the trajectory of crude oil production is smooth. The trajectory of pipelines coming on is not smooth at all. It's very, very lumpy. So anytime we end up being late, then we're going to end up with a pipeline capacity constraint and most likely some sort of implication for basis. And that's the lesson from all of this, is that whenever there's a pipeline capacity constraint, there's a basis. We're on the verge of one right now. Well, fortunately, the midstream industry has been doing a really good job of plugging into all of this stuff. There's a number of pipeline projects that have been built over the last few months that are in the process of being built right now. So the Energy Transfer Sunoco project, this is the Longview extension, 100,000 barrels a day in the second quarter of 16. Magellan Bridge Tech expansion, 100,000 barrels a day in the first part of this year. Plains Cactus expansion, 140,000 barrels a day in the second quarter of this year. Two projects are in the process of starting up. The Permian Express 3 expansion, it's 100,000 barrels a day incremental. The big one, the Midland to Sealy pipeline, where'd that go? Let's see, where's Midland? Yeah, Midland to Sealy pipeline, that's the big one. That's the Enterprise pipe, 450,000 barrels a day. Understand that they're probably doing line fill right now, and they're probably going to be moving crude before the end of the year, although it's going to be a while before it's cranked all the way up. Then by the time we get out to 2019, there's a number of projects that are coming on. Techstar Logistics Epic project, somewhere between 254 and 100,000 barrels a day. Buckeyes South Texas Gateway, 400,000 barrels a day. Plains Basin Expansion, 350,000 barrels a day. And notice the interesting thing about the Plains project is it's not going to the Gulf Coast, it's actually going to Cushing. Presumably with the expectation that once the crude oil gets to Cushing, it's going to be able to find its way from the Cushing back down to the Gulf Coast again. I don't know, that would worry me just a little bit. But nevertheless, the Buckeye project, the Techstar project are targeting the Gulf, and note that they also are not targeting Houston, they are targeting Corpus rather than Houston. So there's a lot of things that are going to be changing down there in that marketplace. So that's kind of what's going on out of the Permian. Constrained now for crude oil, probably going to be less constrained over the next few months, going to be reconstrained by the time we get out to the latter part of 2019, early part of 2020. What about Cushing down to the Gulf Coast? So we can look and see all those pipelines out of the Permian. It's pretty easy to see what's going on. It's less easy to see what's happening on individual pipelines going from Cushing. However, we have a fortunate accident of geography, I'd guess, that the volumes on Pad 2 that flow into Pad 3 on pipelines are pretty much exclusively on those two new pipelines that were built out of the Cushing and into the Permian, the Seaway Pipeline and the Trans-Canada Market Link Pipeline. So we can look at the sum of what has happened on those two pipelines and have a pretty good idea as to what's happening with capacity on those lines. So this is just straight EIA data showing that there was less than 200,000 barrels a day back in 2012. Now we're up to 1.4 million barrels a day, and we were going up and to the right. August is the last data that we have as of today, and you can see there's a dip down in August. Of course, that's the hurricane, right? So I wouldn't read anything into the fact that we've got a dip there. If we look at the capacity, it would appear to be that is the capacity of those two pipelines going down to the Gulf, both Seaway and Market Link, that there would be enough capacity. But in fact, there's a lot of scheduling issues on these pipelines. They're batched pipelines. They do not run at full, they cannot run, they have not run at full capacity. Our view is that they cannot run at full capacity, and therefore when you haircut those pipeline capacities down to what they can probably actually run, the reality is that those pipelines, as we are seeing them today, are pretty much full. Now, DAPL is in the process, Dakota Access Pipeline is in the process of ramping up right now, and so as we see the DAPL numbers start rolling into these PADD 2 to PADD 3 numbers, it's going to be a little more confusing. But what this says, bottom line on this slide, is that not only are pipes out of the Permian to the Gulf Coast pretty much full, pipelines out of Cushing to the Gulf Coast are pretty much full, and that's why you see the pipeline capacity issues and the price differential that we've seen in the market so far. Well, if it was crude oil and that was the only thing that Permian producers had to worry about, that would be just dandy. But unfortunately, like we've talked about a couple of times so far today, there's a problem for Permian producers in terms of natural gas. This is our natural gas production forecast out of the Permian, getting up to 12 BCF in dry gas production by the time we get out to 2022. There are 2 new pipelines that have been built over the course of the last few months. One of them is Energy Transfer, or both of them are Energy Transfer. One of them is Trans-Pecos, the other is Comanche Trail. Those are those 2 hatch lines that you see there. So if we look at that production line, the line that goes up through those hatched capacity areas, and how high the production, the capacity gets at 10 million barrels a day, you'd say, hey, there's no problem. We can get all the way out to maybe nearly 2021 before there is a natural gas problem on our hands out of the Permian. Well, unfortunately, that's not true. Because those pipelines, Trans-Pecos and Comanche Trail, and to some extent Roadrunner, a One Oak pipeline that also goes to Mexico, are not exactly running full. It's 3 million barrels a day, 3 BCF of capacity, running 250 million a day. That's it. What happened? Well, they built the pipelines, but nobody built stuff on the other end. They didn't build the pipelines to take the gas away from the border. And they didn't build the power plants to use the gas that if they did take it away from the border, where would it go? So for 3 BCF of that, it's not flowing. And by the way, it's not gonna flow for a number of years. Some will, it will increase over time, but it's only gonna increase over time and never get close to the 3 BCF a day. What does that mean? Look carefully at the slide. That says that the problem is coming to Permian producers in 2018. There ain't enough capacity. Now, that's a key issue in this whole discussion about infrastructure. There is enough pipeline capacity, but it's like a bridge to nowhere, right? It's pipeline capacity that gets you to Mexico, but there's nobody at the other end of the pipe. And therefore, the pipeline capacity doesn't do you any good, and it doesn't do Permian producers any good, and therefore Permian producers could be facing a situation of natural gas pipeline takeaway constraints as early as next year. That is a very, very significant possibility, because we've never seen that before. We've never seen associated gas in a constrained takeaway capacity situation. 10 years ago, we had a constrained capacity situation out of the Rockies. There wasn't enough capacity out of the Rockies. The price in the Rockies went to a nickel. And what did producers do? They did 2 things. They signed up to get a new pipeline built called REX, and they cut back their drilling because there wasn't anything they could do with their gas. They were motivated to cut back on their drilling because the price of gas is what drove the economics of their wells. What is driving the economics of the wells in the Permian, as we've heard all day long, has nothing to do with gas. It has everything to do with crude oil. So there's nothing that's going to make the folks at XTO slow down their drilling because they don't like the price of natural gas. Because they like the price of crude, and they like the price of the NGLs they're going to get. They just don't like the price of the natural gas, but it's not enough to kill their economics. You saw those economics that we looked at a few minutes ago. So it is a weird situation that we could be heading into as early as next year, all based on infrastructure, gas infrastructure, not crude oil infrastructure. Well, you know, we're supposed to be talking about scoop and stack here too, so I thought, well, let's divert over and talk about scoop and stack, and that's the way we carve up the areas of scoop and stack. And by the way, I'm as far away from a geologist as you can get. So we call these things by names that probably have nothing to do with the geology. So our scoop and stack is in the area of that dark blue up there that we call the Canna Woodford. And that set of 11 counties there, of the 130 some odd rigs that are drilling in Oklahoma right now, 101 of them are in those 11 counties. So by my definition, that's the scoop and stack, and that's what counts. And the rest of Oklahoma, you can see from what was being drilled in 2014 versus what was being drilled in 2016 when things kind of bottomed out versus where they are right now. Most of the rest of Oklahoma is not doing anything. Everything is happening inside that those blue counties right there. And as you might expect, that's where production is increasing. Oh, by the way, for crude oil, again, those blue counties are right next door to Cushing. So it is going to be pretty darn unlikely that we run into a capacity constraint for crude oil, because not only can we get to Cushing via pipeline, if we run out of pipeline capacity, we put it on a truck and take it over to Cushing and load it into tanks over there. So we're not going to run into any problems. That, though, is something worth staring at just for a minute. That's what's happened so far in the stack and scoop, or in Oklahoma in general. And what it tells you is that although that Canna Woodford area, those blue counties, have been growing like gangbusters over the course of the last 3 years, the rest of Oklahoma has declined. So at least from 2015 until now, total Oklahoma production's flat. It's Canna Woodford that's growing. From a capacity constraint standpoint, by definition, we can't be running into a capacity constraint problem, right? Because we've not producing any more crude oil out of Oklahoma than we ever were. Now, all those issues that I talked about a few minutes ago that are affecting Cushing, they definitely are in play, but it's not got anything to do with stack and scoop. Stack and scoop just gets to Cushing as long as it's crude oil, but not if it's natural gas. If you look at that blue area on the natural gas curve, it's the same thing. Everything else in Oklahoma is declining. Scoop and stack is increasing like crazy. And we are, similar to Texas, similar to the Permian, at the ragged edge of exactly how much pipeline capacity is available to get natural gas out of that region. That's our forecast for each one of those regions out of the scoop and stack area. What that says is we're going to get from, you know, somewhere around a little above 6 BCF now up to about 7.5 BCF. And it's not just getting out of Oklahoma. I've got to get out of those blue counties and get into pipelines that are getting out of that region. Fortunately, again, there's pipelines that are doing that. But there's another problem. This area also receives gas from other places. What is one of the places that this area has traditionally received gas from? Darn it, it's the Permian. The Permian's growing like crazy, so the Permian is shoving more gas into this market, not less gas, because it's the only place that Permian's got left to go. Where else? From the Rockies. Rockies is not increasing, Rockies is about flat. But nevertheless, there's no place else for Rockies to go because it is increasingly being thrown into competition with Marcellus and Utica gas. And I'll show you how that plays out in just a second. So that means I got to get out to the Midwest. If I get out to the Midwest, I'm going to run slap dab into natural gas production coming from the Marcellus Utica. And therefore, I want to go to the Gulf Coast. And Cheniere has developed a pipeline called Midship in order to get that production out of that region. One thing I didn't mention a few minutes ago, those pipelines that are getting out of the Permian and Midship that's going to resolve the issue at scoop and stack level for natural gas, none of these pipelines come on until 2019 if they get all the approvals from both shippers and regulatory approvals in order to get built. So we've got a really strange period of time facing us now between now and 2019. So this slide kind of puts the whole thing together, because these basins, the Scoop and Stack and the Permian, are not operating in a vacuum. They are operating in a U.S. continental marketplace, and that continental marketplace has got a heck of a lot of gas coming out of it. Marcellus and Utica is the fastest growing natural gas market in the country, is going to continue to be so over the next few years, going to grow up, 15 BCF in the next few years. As that production has increased, the vast majority of it has displaced gas that used to come into the Northeast market from the Gulf Coast. Now those pipelines are being reversed, and a lot of gas is moving on reverse pipelines down into the Gulf Coast. That's a good thing, and it's a good thing we've got Mexico exports and LNG exports that are helping that happen. Also, over the last few years, a lot of that capacity has been relieved by the Rex pipeline. Rex pipeline reversed. Was flowing about 1.8 BCF going to Ohio. Now it's flowing, I think it's 4 BCF or so going the other way. About half of it splits, goes north, half of it goes south. There's almost no gas that goes into that entire Midwest area from the Gulf Coast anymore. And by the way, parts that I mentioned, it was supposed to mention that I forgot to, was all of this gas that's coming from the Northeast is all targeting that Southeast Gulf region, which is the only place in the country where any demand is growing whatsoever. That's also where the Permian wants to go. That's also where the Stack Scoop wants to go. The Rockies, on the other hand, the Rockies really would love to go to the West Coast. But the West Coast has decided that hydrocarbons are evil, and solar is better, and wind is better, and hydro this year is better too. So there's no gas that can move that direction. So increasing volumes, not decreasing volumes of Rockies gas, increasing volumes of Rockies gas are moving eastward, competing with that Marcellus Utica supply, Stack Scoop supply, and Permian supply, all trying to drop into that funnel and get into the Southeast Gulf and get to Mexico and get to LNG exports. Up on top of that, what do we got now? We've got Rover and Nexus sometime soon. And that gas is a lot of it is getting shoved up into Dawn, Ontario, which needs more gas like it needs a hole in the head. Therefore, it is displacing gas back to Chicago, which doesn't need any more gas, which is displacing gas back into that same Southeast Gulf region. So bottom line on all of that, all the way across, is that there is a lot of gas looking for a home outside that red outline box around the Southeast Gulf, and therefore prices are going to be lower outside that box rather than higher, because there's not enough demand outside that box, and there's not enough supply, there's not enough capacity to get that gas inside the box. Therefore, prices are going to be under pressure every place else but the Gulf Coast. Well, that's about it. Sorry, I didn't have better news for producers than I do. All it does say is that better have some pipeline takeaway capacity, otherwise you ain't going to like the local price.
Wow. Okay.
Got all that?
Yeah. So ending on an upbeat note, I thought I had a chocolate chip cookie and I got raisin oatmeal. Jeez. A lot of content. So we've seen the resource potential is enormous.
Are you buying LNG companies, Rusty?
Yeah, I'm long LNG. As long as LNG flows, LNG's got to flow. Because if LNG doesn't flow, the forward curve right now cannot happen. Forward curve's $3, right? $3 cannot happen if LNG does not happen.
Yeah, so the next piece that we should have laid on this was the permitting and construction of LNG export facilities and how fast we can bring them on. Because right now we have one, right? So
yeah, these guys at the end of this row over here, they want them to happen tomorrow.
I know. No, I understand that fully. All right, Jonathan.